Hi, Pre-Calc Nation. We are finally at the part of Chapter 8 where we get to graph. So today we're going to focus on the graphs of sine and cosine, really focusing on one period. So that means one time around the unit circle, and that's what we're going to graph. A couple of vocab words we want to look at right away is period. So when I say period, this is what we mean. It is the minimum distance to repeat the pattern. That's period. So if I look at this picture on the left, I notice that right here, when x is 6, it's at its lowest point. Then it goes up, back down, up, and you'll see it'll keep going. Here is where the period length would end. It's one of the pattern. The pattern is go up, go down, go up, go down. So during an up, down, that period length is 6. So in this case, P, or period, I guess I can just write it out, is 6. And all you just say is 6, whatever unit it is that it will repeat the pattern. If I'm looking at our example of G, notice this pattern's not as rigid as up, down, up, down. It's curvy up, cross the middle, curvy down, back here. So when I try to find a full pattern, I can start anywhere I want. So maybe I'll start here. No rhyme or reason. Now I have to repeat this pattern. I have to go from here, I have to go down, I have to go up, and then stop here. That is one full period length. That's the pattern. Down, up, down. You have to go back to the same position. So in this case, the period length would be between here and here. Well, adding that up, here's pi in this direction, pi in this direction. The period is 2 pi, whatever the x-axis unit is. So it's just the minimum distance to repeat the pattern. You can look anywhere on the graph. I can even take here, move this to maybe here. Well, that's still a period of 6. Move it to here, wherever you want, as long as it repeats the pattern. So that's our first vocab word. Our next vocab word is what's called amplitude. So the amplitude is the height of the function. I'm going to even write a little formula. It's big M minus little m divided by 2. Oops, as I throw the page. Big M is the max y value you have. Little m is the smallest, the minimum y value you have, and you divide it in half. So for this, I'm actually going to zoom in. If I go here, this is my big M. That's the highest the y value goes. Notice it's constant, right? It always is 4 as my max. My minimum is down here, my little m. The smallest y value that this graph has is at 2. So what I'm going to do is take those together, subtract them, and then divide by 2 to find our amplitude. So the amplitude, if I draw this line in the middle, is the height, and that's a bad idea, I'll do it in red, is the height from the center to the top and to the bottom. That's the amplitude right there. So let me show you what that looks like. So the amplitude here, the highest y value is 4, subtract the lowest y value is 2, divide it in half, I get an amplitude of 1, which is actually shown right here. But the distance between 3 and 4 is 1. That's the amplitude. From the center up or the center down, that's what's called the amplitude, that height of the function. Looking at the amplitude for part B, my max is right here, my min is right here. So my max is 4. My minimum is -4, so make sure you subtract a -4 and divide it in half. We really get 8/2, so your amplitude is 4. Here is the center of your graph. The distance from the center up or the center down is 4 units. Use the formula if you would like. You also can just look at the graph. Find the center, count up, count down. These are your 2 new vocab words that we're going to be looking at a lot when we talk about all of our trig functions. Now, look at those graphs. Aren't they fun? Let's make one. Let's graph. So we're going to start off, our first graph is going to be sine theta. Now, I put the unit circle here for a reason, because we have now become experts at the unit circle, right? If this is sine, I'm going to bold that sine of pi halves is 1, -1, 0, 0. We know the drill. So all we have to do is think of ourselves as going around this circle and plot that right here. What I mean by that? First point is 0, 0. Right here. Sine of 0 is 0. Right? Right here. Sine of 0 is 0. If I go up, I go to pi halves. So pi halves is going to be the next point I need to graph. Well, looking at my curve, sine at pi halves is 1. So my y value is 1. I plot the point right here. Next, I keep going with the circle. After pi halves, this would be pi. So that's my next point I'm going to graph. And I have to ask myself, what is sine of pi? Well, pi is right here. Sine is 0. So I plot this point right here. Keep going with your circle. My next point is 3 pi over 2. So from here to here, I'm now at 3 pi over 2. Sine is -1. So I plot this point. I'm almost done with my circle. I have to go a little bit further to 2 pi. So 2 pi is my next thing I'm going to graph. Sine of 2 pi is 0. Now you just connect your points, put a nice little curve action to it, and voila, there is your sine function. Couple things about it, the period length. If I kept going around the circle or kept going with my pattern, we'll see that it repeats every 2 pi. So the period is 2 pi. The amplitude, or the height of the graph. My max is 1, my minimum is -1, and I'm trying to find the height between the middle of the graph going up or going down. Well, that height is always positive. It's a height. Can't say you're negative feet high. No, you're 1 feet or negative feet. You cannot be negative feet. Hello. So the amplitude is just 1. Always positive for your amplitude. Always positive height. Let's do another one. Let's see if you can get the hang of this. We're going to now do cosine. So cosine, I'm going to put my little helpers here. If that's 0, this is 0. 1, -1. I already know the 5 points I'm going to graph because it's just like sine. I'm going to graph 0. Oops. I'm going to graph at 0. I'm going to have something at pi halves, pi, 3 pi over 2, and 2 pi. You're going to need a minimum, I'll write this down, minimum of 5 points. So sometimes it's easier just to write them out right away and then follow the curve. Or if you want to go step by step like we did in the sine, that's okay too. So here we go. Starting at 0. The cosine at 0 is actually 1. So here, this is 1. This is where the graph's going to start. Interesting. Follow the curve around. I'm now at cosine of pi halves. Cosine of pi halves is 0. So pi halves, the cosine is 0. Going around, now cosine of pi is -1. Cosine of 3 pi over 2 is still going to be 0, so back up here. Finishing your circle, you now get cosine of 2 pi. Cosine of 2 pi will be 1. And then connect your curve. Looking at it, the period is still 2 pi because my pattern repeats every 2 pi. My amplitude, my height from the middle up, is 1. So the really interesting thing to look at here is that these are pretty much the same graph. If I were to keep this one going, from here to here is the exact thing from here to here. The only thing that changes is I kind of shift my graph to the left. From sine to cosine, I shift to the left 1 pi halves, 1 unit, and I get my graph. So regardless, sine and cosine functions will be this nice curvy shape. The period might be different. It might be condensed or elongated. And the amplitude might be really big or really small. But this is the general shape for sine and cosine. The rest are going to be just examples that we look at. So for example, this is a sine function. So sine of 0 is 0. Sine of pi is 0. 2 pi. Like that's exactly what we had on the front. But now there's just a couple more points thrown in here. You do need your minimum of 5 points. So right here, these would be the minimum. Showing you again the period is 2 pi, the length of the pattern. And our amplitude here is 1. From the center up is 1. You also could use your formula for amplitude of big M minus little m divided by 2. Here's another look at it. You're going to need your 5 points. I do want them labeled, so I'm just going to go ahead in here and add those in. That's pi halves, and this is 3 pi over 2. But this one I just showed more periods, more of the repeating pattern. This pattern right here is repeated again right here. And repeated in the other direction. One pattern is your period length, in this case 2 pi. Now we're going to put in the pieces for ourselves. This is y equals sine of x, so just like the ones we have above. Find the coordinates of each point. Well, many ways to do this. First thing I might do is label 0, 0. I know a full rotation is 2 pi, so this will be 2 pi 0. All right, this is the pattern we've just seen over and over. Oh, we should know that point. When is sine -1? Well, it's -1 at 3 pi over 2. The y value is -1. Then the pattern keeps repeating both directions. If you wanted to be adding in the pi halves, pi, go for it, right? It's your graph to help you. So moving on a little bit more, I'm going to look at this point. Well, here is one rotation. So I need to go about a quarter of the way. So think of the unit circle. Bing. Get my X and Y axes. Right here, I just did one full rotation to get me here. Well, I need to go just a little bit more to find this next hill, this next maximum point. Well, after 2 pi, if I go a little bit more, that's actually 5 pi over 2, y value of 1. You can do the same thing in the negative direction. You're just going now clockwise around your unit circle. Here would be one rotation. So right here, well, that's not a point I need, but negative 2 pi. I went bing, bing. But if I want this point, I just have to go about 3/4 of the way. Negative 3 pi over 2, comma 1. Notice that this is going to be pi, negative 2 pi. This one would be negative 3 pi. Oh, this is one more away, negative 4 pi. And you can verify it with your unit circle to make sure that at those x values, your y value is 0. So here, hopefully you labeled all your points. And it's all about our unit circle, everything we have prepared for. Here we go with a little bit period amplitude practice. We've talked about this, that the y value repeats after a set amount is called the period. Here's the amplitude function. So let's take a look. I can pick any value I want. Maybe I'll pick this one. Looking to it to repeat the pattern, it ends right here. So from here to here is my period length. Now each line looks like it's 0.5. So really the period is 2, the length of one repeated pattern. Amplitude, I have to find the middle. So that means take the maximum, which is 1. Write the y value of 1. Minimum is 0, so subtract 0, divide by 2. So my amplitude is 1/2. So I would find the middle. Counting up or down would be about 1/2 in each direction. No matter which way you went, it's going to be positive. Last example, what if I picked this y value, follow the pattern, it ends here. So between here and here is my period. Looks like each line is 1. So I have 5, 6, 7, 8. Negative 8 on the left, 2 on the right. Distance, people. We want distance, so that distance is 10 units. If you don't want to look at the negatives, right, maybe negatives confuse you, just move your points. Find the next 2 that you like. Then you can see it's the distance from 2 to 12, which is definitely 10. So it doesn't matter. Amplitude, same thing. You can look anywhere you want for the amplitude. Amplitude, take your max value. In this case, the max value is -4. Your minimum value is -9. Divided in half. So you get an amplitude of 5/2 or 2.5. So that means from the middle, oops, the middle is about 2.5, 2.5. So there's your amplitude from here to here and here to here. Sometimes it's easier to look at the graph. Sometimes it's easier just to do the equation. Whichever one is best for you is best for me. And let's practice those period and amplitudes. If you have questions, please bring them to class.